So, imagine you're just strolling along a deserted beach. With every step you take, you leave a footprint in the soft, yielding sand. Each print is like a record. It holds, information about your journey. It tells a story of your weight, your direction, and the moment you passed by. Now, lift your eyes from the sand and look up at the night sky. See the countless stars, shimmering like distant diamonds. Each twinkle of starlight is, a messenger from the past. It has traveled across vast stretches of space and time to reach your eyes. This light carries tales of a star's birth, its life, and perhaps its dramatic end. It's like a chronicle of cosmic history delivered right to you. This simple idea that actions leave traces is at the heart of a profound and exciting theory. What if the universe itself behaves in a similar way? What if every single event, no matter how small or seemingly insignificant, leaves an indelible mark on the very fabric of reality? This isn't about footprints in sand or light from ancient stars. It's about something far more fundamental. It suggests that the cosmos is not just a stage for events to unfold, but an active participant, a cosmic scribe meticulously recording everything that ever happens. Every collision of atoms, every thought in your mind, every supernova's explosion. This concept is what we can call the quantum memory matrix theory. It proposes that the universe is, in essence, a colossal memory bank. Think of it as the ultimate secret diary, one that forgets nothing. The theory paints a picture of a cosmos, interwoven with an invisible grid, a matrix of quantum information. Every particle, every wave, every interaction is logged within this matrix. The universe isn't just expanding and evolving, it is accumulating a perfect, unbroken record of its own history. This idea transforms our view of empty space from a void into a rich tapestry of stored information. So, the next time you take a simple step, consider the possibility that your movement is being registered in a universal ledger. The energy you expend, the path you take, the very intention behind your action. It might all be encoded into the quantum structure of the cosmos. This isn't just a poetic notion. It's a concept rooted in the strange and wonderful rules of quantum mechanics. It invites us to see ourselves not merely as inhabitants of the universe, but as active contributors to its ever-growing memory. We are all authors, writing our stories into the great cosmic book, one moment at a time. So, how could the universe possibly remember everything? Well, the answer lies in the bizarre world of quantum mechanics. You see, at the smallest scales of reality, things don't behave as we expect. Particles can be in multiple places at once, and they can be mysteriously linked across vast distances. So the quantum memory matrix theory leverages these strange properties. It suggests that space-time itself is made of unimaginably tiny units or cells. You could think of these as the universe's pixels. Each one of these quantum cells is not just an empty point in space, but a tiny bit of a universal hard drive, capable of storing information. Every time something happens, a photon of light bounces off a leaf or two galaxies begin to merge, the information about that event is encoded into these quantum cells. The state of the particles involved, their energy, their momentum, it all gets imprinted. This process would be happening constantly everywhere throughout the entire cosmos. The universe, in this view, is an active information processor. It's not just a passive container for matter and energy. It is actively recording the state of all its contents at every single moment. This creates a detailed, layered history of everything. This universal memory wouldn't be like a book you can just open and read. The information would be encoded in the quantum states of the cells themselves, in the spin of particles, in the vibrational energy of space-time foam. It would be deeply encrypted, woven into the fundamental structure of reality. To access it, you would need to understand the language of the cosmos itself. This is where the world of quantum computing comes into play. The principles that might one day allow us to build powerful quantum computers are the very same principles that could govern this cosmic memory matrix. So, the theory envisions a universe that is fundamentally computational. Every interaction is a calculation. Every moment adds a new layer of data to the matrix. The past isn't gone, it's simply stored in a different format, distributed across the quantum fabric of space and time. It's a staggering thought. The echo of the Big Bang, the formation of the first stars, the evolution of life on Earth, and even the conversation you had this morning. All of it might still exist, perfectly preserved in this hidden quantum archive, waiting for a consciousness advanced enough to read it. So, one of the biggest head-scratchers in modern physics is this thing called the black hole information paradox. Basically, Black holes are like these cosmic vacuum cleaners, right? Their gravity is so intense that once something crosses the event horizon, yeah, it's gone for good. Not even light can escape. But here's where things get weird. What actually happens to all the information about the stuff that falls in? See, quantum mechanics is super clear about this. Information can't just, disappear. It can get scrambled or changed, sure, but the core info, it's gotta stick around. So like, what happens when a star, full of all this crazy complex information, gets gobbled up by a black hole? Physicists have been arguing about this for decades, honestly. And then Stephen Hawking comes along and says, hey, black holes actually evaporate over time thanks to something called Hawking radiation. But if that's true, it kinda looks like the information just vanishes. Which, yeah, would totally break one of the main rules of quantum physics, but here's where the quantum memory matrix theory steps in and, well, kind of throws us a lifeline. It's actually a pretty beautiful idea if you think about it. The theory says, hey, the information isn't really lost inside the black hole. Instead, it gets, stamped onto the quantum fabric of space-time right at the event horizon. So, picture the event horizon not as a one-way trap, but more like a cosmic scanner. As stuff falls in, matter, energy, whatever, their quantum info gets copied and saved onto this universal memory matrix. The original thing might get crushed out of existence, sure, but its blueprint is still there. It's kind of like tossing a book into a fire, but only after you've scanned every page and uploaded it to the cloud. The book's gone, but the story? Yeah, it's saved forever. This whole idea is cool because it brings together two huge fields, astrophysics and quantum computing. Black holes? That's astrophysics and general relativity territory. But how information is stored and conserved? That's all quantum mechanics and information theory. The quantum memory matrix theory says, hey, the event horizon is like a natural bridge between these two worlds. It's basically the universe's ultimate read-write head, making sure the cosmic story keeps going, even when some of its characters, well, seem to disappear for good. So, the quantum memory matrix theory, if it turns out to be true, would totally change how we see our relationship with the universe. I mean, it would mean that the cosmos isn't just this cold, indifferent void, but a living, evolving repository of history. It changes everything, right? So, the past wouldn't just be this abstract concept, like a collection of memories and historical records. Instead, it would be like a physical reality, encoded and woven into the very fabric of the space we live in. The universe would be like this four-dimensional sculpture of information, where time isn't just a river that flows away, but like a landscape that we could, in theory, revisit. This perspective gives our existence a new kind of permanence. Every action, every choice, every fleeting moment contributes to the cosmic record. It suggests a form of immortality not for our bodies or our consciousness, but for our information. The legacy of our lives, the sum total of our experiences, would be preserved as a permanent part of the universal tapestry. This is a profound shift from the view of a universe destined for heat death, where all complexity and memory eventually fade into a uniform, featureless state. It offers a cosmos with a purpose, to remember, and, this theory provides a powerful framework for unifying different areas of science. It connects the macrocosm of galaxies and black holes with the microcosm of quantum particles. The language of quantum computing, qubits, entanglement, and information processing becomes a fundamental language for describing the cosmos itself. Space science is no longer just about observing distant objects. It becomes a quest to understand the operating system of the universe. It suggests that the same rules that will power our future technology are the ancient rules that have governed reality since the Big Bang. Ultimately, the quantum memory matrix theory invites us to look at the universe with a renewed sense of wonder. It tells us that we are part of something unimaginably vast, not just in scale, but in memory. We are living within the greatest story ever told, because the universe itself is the storyteller and the library in which the story is kept. It's a cosmos that remembers the starlight, the galaxies, and the steps you take on the sand. We are not just fleeting visitors. We are part of the permanent record. We are written into the memory of the stars.